class. I hope you are well wherever you are. I am still your teacher talking from your online classes. We talked last week, and I'm happy to speak to you again this week. Last week, we discussed crude oil and petrochemicals. We discussed the meaning, origin, and formation of crude oil last week. Let's revise our memory again on what we discussed last week before we go into what we have this week. Let's go back to the meaning of crude oil again. I told you last week that the word crude oil or petroleum came from two Latin words. The word crude oil or petroleum came from two Latin words. The two Latin words is simply the first one, petra, meaning rock, and oleum, meaning oil. And then, when the two words were joined together, we have the meaning of crude oil, which means rock oil. I told us last week that the mineral crude oil is composed of many hydrocarbons. It's not a single mineral. It's made up of many hydrocarbons. Now we talk about the origin of crude oil or origin of petroleum industry. We said that the petroleum industry came into existence in the year 1959 when Colonel Edward L. Drake drilled the first well after finding oil in Churchill Valley, Pennsylvania, in the USA. He was the first person to discover an oil well in 1959 in USA. Then I told us that Nigerian crude oil was discovered in the year 1956 at a place in Rivers State called Oloibo, but it wasn't mined until late 1959. That was when our crude oil industry came into existence. Then we talk about formation of crude oil. How is this crude oil formed? They told us that it is formed from remains of dead plants and dead animals of aquatic organisms. That crude oil or natural gas is formed from remains of marine plants and dead animals. When this organism dies, their remains gradually settle on the seabed. And when they settle on the seabed, over the years, the remains become covered with mud, silt, and other sediments. Then the sediments try to pile up, that is, become accumulated into what we call oil wells in large quantities. When they accumulate or pile up, they exert great pressure on their mass, exert great pressure on the lower layers of the earth, which as a result of such pressure, high temperature is also required, which changes those remains of dead plants and animals in the sea changes them into sedimentary rocks. I said that crude oil is a sedimentary mineral. You won't find it in any other rock except sedimentary rocks. Then as a result of pressure again, the sedimentary rock is now converted to mineral oil, which we call crude oil. So, this crude oil, as I told you, is composed of many hydrocarbons, which is what we will see today. We will see how the crude oil is mined, distilled, and then the components of crude oil. And let's now look at the components of crude oil. Just as we said, it's not a single mineral. It is composed of many hydrocarbons. And I told us last week that it is highly valuable, that people call it black gold. Nothing found in crude oil is a waste. But when you see it, the raw crude oil, it is as if it is useless. It is almost useless until it is subjected to what? Refining. Using what? A furnace under high temperature. And then such a place is called what? A mining industry. So when we mine crude oil from the ground, we now send crude oil into what? Refining industry. And the method of refining using crude oil is what we call fractional distillation. This is a separating technique. Separating technique used in separation of crude oil into different fractions. Because it is not a single mineral, its method of separation requires that in a furnace where crude oil is refined, is divided into what we call fractions, so that each fraction will just separate out on reaching the temperature that it requires for it to separate. It will separate out following its own column and come out as a pure liquid. So, in a fractional distillation of crude oil, the process is where crude oil is now refined to separate into different portions. Separation of crude oil into different portions. That is what we call fractional distillation. Turn of crude oil into different fractions. Different portions called fraction. So crude oil is not what? A single mineral. It's composed of many things. Then let's look at industrial fractionation of crude oil. Just as I told you that the method involved is fractional distillation. The distillation process is carried out in huge fractionating column or towers. The distillation process is carried out in huge fractionating columns or towers, each standing some 40 to 50 meters high and 7 meters across. So the fractionating column, I said that the height is between and 7 meters across. The crude oil is preheated to about 400 degrees centigrade in an electric furnace, where about 75% of the crude oil is vaporized. Yes, when you heat them, they turn into vapor. 75% of it is turned into vapor. In these fractions, there is what we call condensers in those furnaces. The mixture of hot vapor and liquid will now flow through the fractionating column and do what? And condenses into different type of fractions, which you will see. We have up to 7 or 8 fractions, but we will discuss 4 today because of our time. So I told us that fractional distillation is a method of separation of crude oil into its fractions, or different portion called what? Fraction. In a fractionating what? Column. Using what? High temperature of up to 400 to 500 degrees centigrade. I said that the furnace has what we call fraction or trays, just like separate fraction or trays. Then let's now see about 4 of each fraction of crude oil. You have the first one, petroleum gases. Petroleum gases is one of the first gotten. These gases are liberated at the top of the column at temperature below 40. So these people are gotten at temperature below 40 degrees centigrade. That is maybe from and then the hydrocarbons gotten there consist of 1 to 4 carbon atoms. We have examples. Examples are they are used as fuel. You know what fuel means? As source of energy for homes and their industry. A good example of this gas is our cooking gas at home that is stored under cylinders. So that is our petroleum gas. Just as I told you last week, that what Nigeria is known mostly is petroleum, not petrol. That is what we are referring to, natural gas. That in the world, we are the second largest producer of these petroleum gases. So these gases are mainly used as fuel for homes and industry and for manufacture of many products. These are petroleum gases. These are mostly gotten as gases. They are not liquids. They are gases. Then we have the second fraction, petroleum ethers and hydrogen. This mixture of very volatile liquids. These are mostly volatile liquids. If we talk of volatile liquids, we are referring to liquids with low boiling points and low melting points. If we talk of volatile, initially we hear volatile liquids. They are talking of those liquids with what? That have low boiling points. We have examples like methylated spirit. Methylated spirit. You know that one very well. Even our methanol and ethanol, they are made up of these liquids with low boiling and melting points. Is what we call volatile liquids. This mixture of very volatile liquids consists of hydrocarbon with 5 or 7 carbon atoms. That is, they consist of 5 to 7 atoms per molecules. The petroleum ether or light petroleum distills over. The temperature of distilling is between 22 degrees temperature is from 2 degrees centigrade to 60 degrees centigrade. See that these people, as we go up, as the carbon atom increases, temperature of refining increases. These people are below 40. You see this one from 2 degrees to what? 60. That is when you get petroleum ether and then regrowing. While regrowing or light naphtha distill between 60 to 100. Okay. This one distills. See that it has a higher boiling point than the petroleum ether. Regrowing distills. Then both products are used as organic solvents. That is, we use it in dissolving. Organic solvents like what we use in dissolving paints. If you go to paint industry, they don't use ordinary water to dissolve them. They use this petroleum ethers and regrowing. So they are used as organic solvents. Then we have petrol or gasoline. That is the common one. So that people use to call everything petrol. It's a mixture of hydrocarbon consisting of 4 to 12 carbon atoms per molecule. Yes, you see that the carbon atom is increasing. Consists of 4 to 7 carbon atoms per molecule. And then these are volatile liquids too, which distills over in temperature range of 40 to 200 degrees centigrade. Temperature range or temperature of separation or distillation. Is between 40 degrees, 40 to 200 degrees centigrade. Yeah, this is the one that we use in an automobile for driving. Petrol. You don't want to call them petrol, you call them gasoline. So these are mostly used as fuel for aeroplanes and motor vehicles. They are used as fuel. It is also a good solvent for paints and grease. Yes, they are also used as organic solvents for paints and grease. If you want to dissolve something that doesn't dissolve in water, you know that organic substances do not dissolve in water. It's only inorganic substance that can dissolve in water. So if you want to dissolve any organic substance, you look for what? Organic solvent, just like this petrol or gasoline or petroleum ethers. They dissolve in there. Then let's now talk about the fourth one, and we call it the kerosene, the one that we know very well. Kerosene. You see how they are separating. And this kerosene contains hydrocarbon with 12 to 18 carbon atoms per molecule. Consists of 12 to 18 carbon atom per molecule. It consists of 12 heat in a furnace. Then it is used, its temperature of distillation is and heating, and for driving tractors and some modern jet engine. It is used for lightning and heating, especially in our land, and also used in driving tractors, and some modern jet engines. Then it is also used as good solvent for grease. When we come next week, we will discuss other components. So I told us today that crude oil has many components. It's not a single mineral. It's made up of many hydrocarbons. We started from petroleum gases, and they are the first to be distilled when crude oil is subjected to heat. The petroleum gases separate first, and I told us that the petroleum gases contain from 1 to 4 carbon atoms per molecule. The temperature of separation is between 1 degree centigrade to 39, that is below 40 degrees centigrade. And I gave you example like methane, ethane, and butane. And I told you that they are used mainly as fuel for homes and their industry. I gave you a good example, our cooking gas. It's an example of petroleum gas. Then we have the petroleum ethers and hydrogen. So it's made up of from 5 to 7 carbon atoms per molecule. Temperature of distilling is between 2 to 60 degrees centigrade. Then hydrogen, I told you that it separates at temperature between 60 and 100. Then they are used mostly as organic solvents, especially for dissolving of paints and grease. We talk of petrol or gasoline. This one consists between 4 to 12 carbon atoms per molecule. Temperature of distilling is 40 to 200 degrees centigrade, and they are used as fuel for homes also, and aeroplanes and motor vehicle. The fourth one, kerosene, which consists between 12 to 18 carbon atoms. Temperature of distillation 200 to 250 degrees centigrade, and I said that it is fairly volatile, and it's used for lightning and heating, used in driving tractors and some modern jet engines. It's also a good solvent for paint and grease. So you can call it a day here today. You still hear from me. By next week, if you have any question, send it to our platform. We will reach you through our platform. Thank you for paying attention.